record. Okay, so we are on 10.3 now, the new lectures, and today's about the derivatives of products and quotients. So we will learn the product rule and the quotient rule for derivatives today. So first up is the product rule. If f and g are both differentiable, then the derivative of f of x times g of x is given by the formula f prime of x times g of x plus g prime of x times f of x, or to keep it simple, f prime g plus g prime f. And this works for all the other derivative notations, y prime, dy over dx, and d over dx. So let's go ahead and apply the product rule to the next examples. Okay. So first up, example 1. And to start the product rule, we have to label our functions. So the first one will be f, and the second function will be g. So now I'm just going to rewrite those down below. F is 2x squared, and g is 3x to the fourth minus 2. Now what we're going to do is take the derivative of f and g. So f prime is going to be 4x, and g prime is going to be 12x cubed. So we label f and g, we take the derivative of f and g, and now we just apply the product rule. So we are taking the derivative of f of x, so we'll start it off with f prime of x, and now follow your product rule. Your product rule goes f prime times g, so 4x times 3x to the fourth minus 2, plus g prime times f, 12x cubed times 2x squared. And now the calculus is done, the product rule is done, and all we have left to do is clean it up algebraically. So everything from here on out is cleanup. So distribute that 4x, you get 12x to the fifth minus 8x, plus distribute that 12, you get 24x to the fifth, combine like terms, and we get 36x to the fifth minus 8x, and that's it. Any questions on that process? Label F, label G, take the derivatives, apply the product rule, clean it algebraically. Okay, let's do it again. Here's F, and all this is going to be G. So F is 3x cubed. G is 2x squared minus 3x plus 1. Take the derivative, 9x squared, and 4x minus 3. Oh no. Okay. And then, so I'm recording it, Brian, just in case you can't get on Zoom still. So.
Okay, thank you. It's like on and off, and it's super bad.
Okay, all good. This is recorded, so it'll be in the modules hopefully by today.
Okay, I'll have to watch it again later.
All right. So we're taking the derivative of y, so we will write y prime, and once again, just follow the product rule. F prime g, 9x squared times 2x squared minus 3x plus 1 plus g prime f. So 4x minus 3 times 3x cubed. And again, derivatives done. Product rules done. Algebra on from here. Distribute that 9x squared. You get 18x to the fourth minus 27x cubed plus 9x squared. Distribute that 4x minus 3. You'll get 12x to the fourth minus 9x cubed. Okay. Combine like terms. I have an 18x to the fourth, a 12x to the fourth. That'll give me 30x to the fourth. I've got a negative 27x cubed, a negative 9x cubed. That's negative 36x cubed. And then all that's left is that 9x squared. And that was it. There you go. Okay. Any questions so far? Okay. Next page. All right. Do it again. More practice. 3x plus 2 will be our f. 4x minus 5 will be our g. So f is 3x plus 2. G is 4x minus 5. Take the derivatives. F prime is 3. G prime is 4. We're taking the derivative of g of x. So we'll write g prime of x. And again, follow your product rule. 3 times 4x minus 5 plus 4 times 3x plus 2. Calculus is done. Product rule is done. Algebra on. And we get 12x minus 15 plus 12x plus 8. And combine like terms, we get 24x minus 7. There we go. Product rule again.
I got a question, Professor.
Go ahead.
With the derivative, we still keep that constant number in there,
Which constant number?
the 15 and 8.
Yes, because remember, we're not taking the derivative again. So this 15 and 8, we're just combining like terms because the derivative was done already. The derivative was here.
Okay, so it's after the fact we still keep them.
Exactly. So we have f, we have g, we take the derivatives, and then we follow the product rule. After we do the product rule, that is the actual derivative. What I circled right there is the derivative of that function. We just have to clean it up. All right. Yeah, good. Okay. Oops. Oh no. There we go. Oh, so much space. Okay. Again. X squared plus 2 will be f. X squared minus 3 will be g. So f is x squared plus 2. G is x squared minus 3. Take their derivatives. F prime is 2x. G prime is also 2x. We are taking the derivative of h of x. So we'll start with h prime of x. And now just use your product rule. F prime g plus g prime f. So derivative's done, followed the product rule. This is the derivative of h of x, but again, we have to clean it up. So distribute that 2x. You get 2x cubed minus 6x.
No, no. Hey, no
2x
hagas eso.
cubed
Mira lo que está haciendo, lo que está
plus
haciendo.
4x. All right. Okay. So all you have left to do is combine your like terms, and you get 4x cubed and negative 6x plus 4x. I get minus 2x. All right. Yeah, and that's good. That's 2. Yeah, okay. So, any questions on that one? All right. Okay. E, still product rule. Now you have x squared times e to the x. So x squared is our f, e to the x is our g. So f, we get x squared. G, we get e to the x. And then f prime, we get 2x. G prime, we still get e to the x. Taking the derivative of f of x. So we'll start with f prime of x. And once again, just follow your product rule. F prime g, that's 2x times e to the x plus g prime f, e to the x times x squared. Now that's a suitable answer, but if you want to rewrite it, you can just rewrite it as 2x e to the x plus x squared e to the x, just to put it in order. And then, like I said, this is perfect. But if it asks you to factor, which I don't think it will, you can also factor out an x and an e to the x, and this would leave you with 2 plus x. Okay. All good on that one? Okay. All right. F of x equals x to the fourth times the natural log. X to the fourth will be our f. Natural log will be our g. So f is x to the fourth. G is the natural log of x. F prime, 4x cubed. G prime, 1 over x. Okay. Taking the derivative of f of x, so we get f prime of x, and follow your product rule. F prime g, 4x cubed times the natural log of x, plus g prime f, 1 over x times x to the fourth. Okay. Clean up, and we'll get 4x cubed natural log x plus 1 over x times x to the fourth. That becomes x cubed. And the reason for that is you can rewrite this as x to the fourth over x, which will give you that x cubed. Okay. Now again, this is a great answer, but you can definitely factor it if we just take out the x cubed. And that would leave us with 4 natural log x plus 1. Okay. And guess what? That was product rule. Too easy, huh? So any questions on these before moving on to quotient rule? All right. So now we have quotient rule. So if f and g are differentiable, then the derivative of f of x over g of x is given by f prime of x times g of x minus g prime of x times f of x over g of x squared. Or a simpler formula, f prime g minus g prime f over g squared. And again, this works for any derivative notation, y prime, dy over dx, and d over dx. So let's go ahead and try the quotient rule out. So this time, the numerator will be f, and the denominator will be g. And we're going to do the same exact thing as we did for product rule. F is x squared. G is 2x minus 1. F prime is 2x. And G prime is just 2. So label F, label G, take their derivatives, and now let's set up for product rule. So we're taking the derivative of f of x. So we'll write the notation f prime of x. And now let's go ahead and follow our quotient rule. F prime times g, 2x times 2x minus 1. This time it's now minus g prime times f, 2 times x squared. And now by the quotient rule formula, you put all of this over the original denominator of 2x minus 1, but this time it will be squared. So that's how the quotient rule works. So now all we have left to do is just to clean up the numerator. So distribute that 2x, and you'll get 4x squared minus 2x minus 2x squared over the same denominator of 2x minus 1 squared. Combine like terms in the numerator, and you'll get 2x squared minus 2x over 2x minus 1 squared. Now again, this is a great answer, but you can definitely factor it if you need to. You can take a 2x out and be left with x minus 1 over 2x minus 1 squared. And that's quotient rule. Any questions on that one? All right, let's keep going then. Same thing. Numerator will be f. I'm just going to put a dot. That'll be f. Here's g. So f is t squared minus t, and g is t cubed plus 1. Take the derivatives. You get 2t minus 1, 3t squared. Taking the derivative of y, so we'll start with the notation y prime, and let's go ahead and follow the quotient rule. F prime g, 2t minus 1 times 2t cubed plus 1 minus g prime f, 3t squared times t squared minus t. And you put this all over the original denominator squared. So again, calculus is done, derivatives done, quotient rules done. Now we just have to clean up algebraically. So we have to FOIL these two guys first. So I'll get 2t to the 4th plus 2t minus t cubed minus 1. And then now we're going to distribute that negative 3. Negative 3t squared. So negative 3t to the 4th plus 3t cubed. All over t cubed plus 1 squared. Okay. Combine like terms, and let's look. I have a t, 2t to the 4th, and a negative 3t to the 4th. That'll give me negative t to the 4th. And then I have a negative t cubed, positive 3t cubed. That'll give me, oops, plus 2t cubed. And then I just have a lonely t there, so that'll come down, and a lonely negative 1 there, so that just comes down. all over the original denominator squared. And now there's nothing we can do here. That one is done.
One quick question, Professor.
Go ahead.
How did we get the T3 plus 1 to the second power on the denominator?
That is just by the quotient rule. See that? Look at the denominator for the quotient rule.
Gotcha. Okay.
So it's just by the formula. The denominator, the original denominator, will always be squared.
So we do nothing with the numerator when we get to that point.
Well, for that last problem,
Yeah.
yeah. So for this one, there's nothing that else. It can't be factored or anything else, so we leave it alone, as ugly as it is. And the denominator, you leave it alone. There is no need to FOIL out this denominator unless my math lab asks you to, but it shouldn't. So never FOIL that out. It's
Okay,
just
so on
an
the last
extra
one,
step.
on the last one, the 4x got canceled out because of the denominator being squared. The
No,
4x squared.
the 4x squared. So on this one, that 4x squared and negative 2x squared gave me that 2x squared.
Gotcha. Okay.
Yeah.
So you basically are just combining like terms like for the very last part.
That's it. In the numerator, you only clean up the numerator and you combine like terms. That's it.
Okay.
So you do nothing with the denominator pretty much.
No, don't even worry about it. Just square it and move on. That's it. Okay, cool. All right, let's keep going. All right, d over dx of x squared minus 3 over x squared. Once again, numerator's f, denominator's g. So f will be x squared minus 3, and g will be x squared. Take the derivative of f, take the derivative of g, which is also 2x, and now follow the quotient rule. So we are taking the derivative of x squared minus 3 over x squared. So you don't see a y equals or a f of x equals here. So the way we have to start this notation off is just by rewriting the same statement above. D over dx of x squared minus 3 over x squared is going to be equal to, and now we can finish up using the quotient rule. So f prime g, 2x times x squared minus g prime f, 2x times x squared minus 3, all over the original denominator squared. Okay. Now, once again, like I said, all the calculus is done. The rest is clean up algebraically, clean up the numerator, and we can clean up the denominator too. So I'll show you how. So 2x times x squared, 2x cubed, distribute that negative 2x, and you'll get negative 2x cubed plus 6x. And this time we can actually fix this denominator because x squared raised to the second power becomes x to the fourth. Okay, and then my 2x cubes, we see that I have a positive one and a negative one, cancel. And what we are left with is 6x over x to the fourth. which we can simplify one more step because this x will cancel and this 4 will become a 3. So our final answer is just 6 over x cubed. All right. Any questions on that one? So if you can simplify more, go ahead. In this case, we could with the denominator. In the other ones, you don't have to. All right, again. All right. Numerator is f, denominator is g. F is x squared plus 1. G is 2x minus 3. F prime is 2x. G prime is just 2. We're taking the derivative of f of x, so we start with f prime of x and follow the quotient rule. F prime g, 2x times 2x minus 3 minus g prime times f, 2 times x squared plus 1. All over the original denominator squared. Okay. Everything's done. Just clean it up algebraically now. The numerator. Distribute that 2x. You get 4x squared minus 6x minus 2x squared minus 2 all over the same denominator. And combine like terms. I have a 4x squared here, a 2x squared there. So that will become 2x squared. I have a lonely negative 6x there. So that'll go there. And then a lonely 2, negative 2 there. So that comes down. Over the original denominator squared. Now again, this is a great answer, but you could factor it using one more step just by taking a 2 out of the numerator. And you get x squared minus 3x minus 1 over 2x minus 3 squared. Okay, there we go. Factored. All right.
Hey, Professor,
What's up?
is there ever any time you're going to factor out that denominator further?
If we're going to factor the denominator out further?
Yeah, like is there any time that you have to do that or?
No. I mean, never ever FOIL that denominator unless we have to or we're asked to. But other than that, you just leave it alone.
Sounds good. Thank you.
Mm-hmm. Now, if my math lab makes you do it, I'm sorry. That's just terrible. Okay. All right, cool. Here we go. Again, 1 minus e to the x over 1 plus e to the x. Numerator is f. Denominator is g. So f is 1 minus e to the x. G is 1 plus e to the x. F prime would be negative e to the x. And g prime would just be e to the x. Okay. Taking the derivative of f of x, so f prime of x, and let's do our quotient rule. Negative e to the x times 1 plus e to the x, f prime times g, minus e to the x times 1 minus e to the x. Ooh, look at all those e's. All over the original denominator squared. Okay, and lots of cleanup to do. We have to distribute those e to the x's. So a real quick note on that. Do that over here. I'll say a little side note. When you multiply e to the x times e to the x, well, the rule for exponential bases, the algebraic rule, since these are the same base, what you will do is add the exponents. So x plus x, this is going to give me e to the 2x. This follows the same algebraic rule of x to the m times x to the n gives me x to the m plus n. So whenever your bases are the same, all you have to do is add the exponents. And it goes the same for e to the x. So let's try that out over here. So I don't need that. Let's distribute that negative e to the x, and you'll get negative e to the x minus e to the 2x, and then distribute the other negative e to the x, and you'll get negative e to the x plus e to the 2x over 1 plus e to the x squared. Okay. One final cleanup. We see that my negative e to the 2x and my e to the 2x will cancel. And all we're left with is negative e to the x minus e to the x, which will give me negative 2e to the x over 1 plus e to the x squared. And that's it. Any questions on that one? So just remember your algebraic properties. Okay. Two x over 1 plus the natural log of x, numerator's f, denominator's g. F equals 2x, g equals 1 plus the natural log of x. F prime is 2. G prime is 1 over x. Follow the quotient rule. So f prime of x is going to be f prime times g, 2 times 1 plus the natural log of x minus g prime times f, 1 over x times 2x all over the original denominator squared. Okay. And cleanup time. Distribute that 2 plus 2 natural log x minus, and 1 over x times 2 over x is just going to be 2 over the same denominator squared. And then we see that my 2's will cancel. And we are left with 2 natural log x over 1 plus the natural log of x squared. And that's it. And again, that can be rewritten as 2x over x, which gives you that 2. Yeehaw! And I think that is it. So yeah, that's product rule and quotient rule. Calculus couldn't be any easier, right?
That's pretty cool.
So that's it. We're done.
Can you bring up D? You
Yeah.
did? I missed that one because I got kicked out.
Dun, 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 dun. There we go.